This is chapter 1. This is the #1 recording for scientific notation. We're going to use properties of exponents in scientific notation problems. A number is written in scientific notation when it is in the form c times 10 to the n power. Now, we normally don't use the x for a time sign, but in scientific notation you do. And we normally don't have negative exponents, but in scientific notation that will also be okay. All right, the form, again, is c times 10 to the n power. And c is going to have a proper form, and that form is going to be 1, that c has to be between 1 and 10. It can be equal to 1, but cannot be equal to 10. So it's written as a compound inequality. 1 is less than or equal to c is less than 10. So in effect, you can have a c value that is between 1 and 9.99999. All right, let's go ahead and do letter A. The highlighting is going to be helpful to you. So we're going to use the parts, the 3.2 that are highlighted in the same color together, times 1.5. You're going to want to use a calculator to do this. Again, you're going to evaluate each expression using a calculator, and you're going to write your answer in scientific notation. Again, be careful for the correct form. That is an area where sometimes mistakes are made. 3.2 times 1.5 is 4.8. Then you're going to take the blue highlighted, and you're going to go 10 to the 4th times 10 to the 5th. Well, the base is the same on these. It's 10 on both of them. So you have 4 tens and 5 tens. This is the product of powers when you have the same base. And that gives you 10 to the 9th power because you have 9 tens. So you would correctly write this 4.8 times 10 to the 9th. This one's quite simple. The ones in your book are not this simple, but this one is in fact quite simple. Now letter B is going to be a little bit more difficult, although there will be some challenges associated with your problems in your book. They are even a little bit more challenging. So we have 5.7 times 6.2. Again, you would do this on your calculator, which would give you 35.34. And then we take the blue, which is 10 to the -6th times 10 to the 8th. Now, 10 to the -6, we're going to go back to those properties of exponents where you don't have a negative exponent. We won't use negative exponents until we get the final answer. So I'm going to say I'm going to make that a positive exponent. So in order to do that, it goes from a numerator position, because it could be put over 1, down to the denominator 10 to the 6th. 10 to the 8th is fine, so we just put 10 to the 8th right here. So you have 8 tens in the numerator, 6 tens in the denominator. 6 of the tens will cancel to 1. You're left with 2 tens in the numerator, 10 to the 2nd. So instead of using the, you could use the product of powers, but instead of using that, we're using the quotient of powers. That way, after we use the negative exponent property, and we end up with 10 to the 2nd. Now here's where you have a bit of a problem. 35.34 times 10 to the 2nd is scientific notation, but not correct form. You cannot have 35. There cannot be a 2-digit number right here. It has to be 3.534, which means the decimal has to move back 1 place. Now, there's a lot of ways you could learn this. Some of you will see it more clearly, intuitively than others, but for those of you that might be struggling as to whether this is going to be 10 to the 1st or 10 to the 3rd power, you either go up 1 exponent or down 1 exponent when you move that decimal 1 place, I'm going to show you a strategy. Go ahead and put 35.34 times 10 to the 2nd in the calculator. 10 to the 2nd is 100, so it's like moving the decimal 2 places. Once you've done that, you will see that you get 3,534 on your calculator. Now, this isn't required. This is a way to tell if you've got the correct exponent. Now, I want to either make this 10 to the 1st or 10 to the 3rd. I know it has to be 10 to the 3rd, but I could check that on my calculator. 10 to the 3rd is 1,000. 1,000 would move the decimal place, 3 points, 3 places, 1, 2, 3 when you multiply by 1,000. So when you put it in the calculator, you would see that it's going to be 3,534. These need to be the same. These are equivalent expressions. And by putting them in the calculator, you're essentially checking that you chose the correct exponent when you rewrote it as an equivalent expression. So 3.534 times 10 to the third is your answer written in scientific notation, correct scientific notation. Again, your problems in your book are going to be a little more challenging than this, but I expect you to get as much done as possible. Letters C and D work with quotients involving scientific notation, and so we want to be able to write the final answers using scientific notation. I've highlighted the parts that would go together in the same color, and so letter C, which is going to be quite simple, is going to be 8.4 divided by 1.4. When you plug that into the calculator, you end up with 6, and then 10 to the 10th divided by 10 to the 8th. This is the quotient of a power because you have the same bases. 10 is the same. You have 10 tens in the numerator, 8 tens in the denominator. 8 of those tens will cancel, and you'll be left with 2 tens in the numerator, so 10 to the second. Now, you might be inclined to write this 6 times 10 to the second, which is in fact correct, but we're going to write the 6 as 6.0 times 10 to the second. That 0.0 is something that you would see in testing in the textbooks and so on. Again, C was quite simple. It's going to be quite a bit simpler than your problems that are in your textbook that you have to do for the assignment. So we're now going to go to letter D. We've got 3.6 times 10 to the negative 5th divided by 4.8 times 10 to the negative 7th. The pairs that are highlighted, the same color, are going to go together. So it's going to be 3.6 divided by 4.8. And that is going to give you 0.75. Again, the calculator problem. Now this one is a little bit more challenging, and the ones you'll have in your book will be even more challenging yet. We've got 10 to the negative 5th divided by 10 to the negative 7. And we don't want negative exponents, so we're going to use that negative exponent property to rewrite it. And so 10 to the negative 5th goes down to the denominator, becomes 10 to the 5th. And 10 to the negative 7 comes up to the numerator and is equivalent to 10 to the 7th. So it's just an equivalent expression. We have 7 tens in the numerator, 5 tens in the denominator. This is the quotient of powers property, which leaves us 5 of those tens will cancel and become 1, which leaves us with 2 tens in the numerator, so 10 to the second. And you're going to end up with 0.75 times 10 to the second. Now, as I've told you before, I would give you half credit for getting this far because you're showing some level of understanding. But this is not the correct form. In order to be in the correct form, you cannot have a 0 in the ones place. So the decimal is actually going to have to move back 1, and you're going to end up with 7.5 times 10 to the something power. Now, it'll either be 10 to the 1 or 10 to the 3. So one of the ways to do this is to plug 0.75 times 10 to the second in the calculator. 10 to the second is like 100. So 0.75 times 100 is 75. Because effectively, you're moving the decimal 2 places to get 75. 10 to the second, you're moving it 2 places. So I know that if I have to have 7.5 and I want to get 75, I'm going to move the decimal 1 place, which means it's going to be 10 to the first. And if you don't see that, then just plug it into the calculator. 7.5 times 10 to the first is 75. If these answers are correct, this is just simply a check. It is not part of your problem. They just ask you to rewrite it or write your answer in scientific notation. This is your answer in non-scientific notation. So these are the same, and that means that these two scientific notation amounts are also the same. They are equivalent. Again, you're going to have some challenges. Your assignment for this is page 299, 36 through 39. You're going to want to use your calculator, and this is again chapter 6.1. You are going to find it rather challenging. Get as much done as possible. We will go over it in class. And then what we'll do is we'll continue to add on problems from other resources so you can really get solid and strong at these scientific notation problems. These are the only problems offered in your book, however.